revolutionary products that were designed using artificial intelligence 10 years ago, by and large, between 8 and 10 years ago, using physics-based models, using genetic AI tools to optimize and improve and evaluate multiple. And we came up with something that no physicists in the past, no people working on electric propulsion could have ever come up with in the time frame they did. We were able to work with Los Alamos as part of this. And so we told them about our thruster, and we were struggling because it didn't fit the standard equations that were used in the industry. And they said, well, do you have experimental data? And we said, yes, we have a lot of experiments. They said, do you have simulation data, physics-based simulations? I said, yes. And they said, are they consistent? Yeah, they're consistent. He says, you don't need no stinking equations.
Hello and welcome to the Auto Intel podcast, the show where we dive deep into the challenges and opportunities shaping the world of engineering and software. Each episode, we sit down with business leaders, innovators, and decision makers to uncover the strategies, insights, and technologies driving growth and transformation in today's digital economy. My today's guest is Brad from MilesSpace. Hi, Brad. How are you? Welcome
Good,
to
how
the
are
show.
you?
Thanks for being on the show.
Glad to be here.
Yeah. So, Brad, just to kick off things, would you just like to give us a brief introduction about what's your background and how did you come to start MilesSpace?
Started my career with Exxon, actually worked in Prudhoe Bay in the North Slope of Alaska. Then eventually went on to the Harvard Business School and got an MBA. Following that, I joined McKinsey & Company, and I was a partner there. In 2000, I started a Internet of Things concept, which that word hadn't been invented for another 15 years, but that was what it was. And I raised, this was in March 2000, I raised about $2 million in a week, given how crazy the internet bubble was. That was when the NASDAQ peaked at 5,000. And I'll note NASDAQ didn't reach 5,000 until about 4 years ago. So it was a very heady time. I sold the company about 6 months later after founding it and moved to Northern Virginia to be the president of the company that acquired us. The good news on that deal was that eventually, when we merged with the company, the combined entity was worth about 70 million, most of which was the acquiring company's value. And that company eventually sold for $1.5 billion. In the meantime, we did a couple of leverage recaps. My investors ended up making about 4x returns. So a good story for as bad as we could have had it in that period. I then joined the Pentagon, and I was a senior official in the Bush administration and early into Obama at the Department of Defense. I ran logistics and supply chain for a year or so, and then I was the director of what's called Program Analysis and Evaluation. That's the group that provides independent advice to the Secretary on how to allocate the $5 trillion that the Defense Department spends over a 6-year period. I left there in 2009 and joined a number of boards, including Boeing Defense and Space on their advisory board for that segment of the business. Then joined another company called, invested in and joined a company called N12. N12 was making carbon nanotubes for carbon fiber composite applications. It was a spin out of technology from MIT. I raised about 30 million for that, and unfortunately that one didn't go as well. And then in about 2001, I joined a space company here in Florida. I now live in Florida. And after that, there was another partner company called MilesSpace that company was working with. And I eventually joined that company and am now the CEO of MilesSpace.
3 years now, right? So, what sort of work does MilesSpace do? Like, what areas they are working on at the minute?
So the founder of MilesSpace, who's the CTO now, is developed a electric propulsion device to move satellites in space. And using artificial intelligence, he actually designed a new way of doing electric propulsion, which was much higher performing. And so he eventually won a contest to place a rideshare on Artemis, NASA's first moon mission or back to the moon mission. And that toaster-sized satellite was sent about 10 million miles from Earth as a rideshare on Artemis. And in order to talk with that small craft, he needed to develop as well some very high-performing minute signal detection that, in perspective, is the size of a toaster 10 million miles away is about the size of one of your atoms relative to your eyeball. So very, very small for that far away.
Wow.
And he was successful in doing that. And we were able to talk to that satellite from a 3-meter dish in 3-meter parabolic dish in Dubai. And subsequently, we've developed that technology and some variants of that technology to enhance satellite communications, all communications in general. And then also minute signal detection is helpful for, we're able to do passive radar by listening to reflections of radio waves off of flying objects, just the passive radio waves that are in the atmosphere coming from cell towers and Wi-Fi networks and transmitters of radio and television. We just listen essentially to that, and then we can see the power reflected off of flying objects, and we're able to detect flying objects with that. We can also do alternative GPS. So we look for radio waves from celestial objects like the sun and the moon and pulsars. And then we can calculate where one must be in space-time if the relative positions of those celestial objects is such. There's only generally one time in space-time when they're all relative to you in those positions. We also can do the ability with this minute signal detection. We can also uniquely identify individual transmitters. In the Internet of Things world, that's called radio frequency fingerprinting. In the intelligence world, it's called specific emitter identification. But it's valuable as a cybersecurity without using crypto. So I can make sure that the devices trying to enter the network are actually the qualified device. Even if we had 1,000 cell phones that have been spoofed to the same IMED or IMEI and all of the other software was identical, there's still small variances in the capacitors and the microprocessors that give away the identity of the specific transmitter. So minute signal detection, digital signal processing, and then in-space propulsion are the two areas of business related by that one mission. Customers don't have a huge overlap. There's a little overlap, but not a lot.
So, I mean, by the sounds of it, you said the electric thruster product is already kind of tested with the NASA's Artemis mission.
Yeah, it was on Artemis. We have subsequently launched 3 of those into space. We have one successful test of one of those, and it performed, again, really, really well at the same as we had proposed, the same as we said. So we were, orders of magnitude better performance in the efficiency and the thrust relative to current alternatives. We have some others that we have for either kind of administrative issues or we have a technical issue on one of them that we're trying to solve right now to get further testing. But we have validated it in space, which therefore makes it technology readiness level 9 for NASA's concern. But again, it performed so well, there's a lot of skepticism in the markets. People want to see more in-space testing to be confident that we're hitting the numbers we've advertised.
Right. So, I mean, are you approaching some other private companies as well, apart from NASA, in terms of the electrical thrusters side of things?
Yeah, thrusters are typically spec'd by the people who make satellites. But NASA doesn't buy satellites. NASA doesn't buy thrusters, NASA buys satellites, and the satellite manufacturer will look at alternatives for propulsion.
Propulsion, sir.
So we are primarily talking to new space, commercial space folks right now who are more aggressive with payloads that are may need this capability, and others they're trying to do something very difficult or are less risk averse than NASA. NASA tends to be fair. It sounds a little ironic, but the space industry is actually quite risk averse. And lots of the technology that's used is actually quite old. You wouldn't think that, but actually people don't like to try new things because it's such a risky endeavor and there's so little room for error that
Yeah, absolutely right. Yeah. So the technology has to be very well validated before the satellite manufacturer starts to have the confidence
exactly.
to, buy it and take it on. Right. Yeah.
Yeah,
Okay.
that's a longer sales cycle from a business standpoint. You're going to spec A thruster probably 18 to 24 months before you're going to launch it. So it's also quite a long sales cycle, which is also
Right.
difficult for a startup from that product
Yeah, so
standpoint.
that's quite long, right? Yeah, 24 months. So even approaching one satellite manufacturer, you have that lead time of about 18 to 24 months before you can sell it to another one.
Yeah, where you can get the revenue. So it's a challenging
Challenging
business
industry
model.
too. Yeah, absolutely. But then you talked about two other products. One you said about what was the digital signal processing
Yeah,
software, is
so
it? And
digital
the other
signal
there is the
processing has our primary product we're working on right now is a signal enhancement product. So we are able to enhance the gain, it's called. So gain is the measure of merit in a uh, link budget, as it's called. So how much noise from the power you generate from the transmitter all the way to when you convert it into uh, zeros and ones again, how much loss is there? How much noise is there in that system? And antennas help you to concentrate the energy. So they add amplification, but they also add some noise in that they're doing things randomly that also affect the electrons that are moving around. Then you put them through a amplifier. That amplifier amplifies that signal, but again, it adds noise. And then eventually it goes into a modem, and the modem tries to filter out the noise and figure out what the signal was. Our product goes in that link chain and enhances the signal by eliminating the noise and making the signal more clear.
right.
It does it in a unique way that's patent pending, and it was the fundamental, technology that was used to have this conversation with this small set that was 10 million miles from Earth. So that's our first product. One of the challenges to doing that, again, this is like the other one, is so massively useful and valuable that it's not accepted. It's very skeptical. This again is people are very skeptical because it's doing such an amazing job. We've compared it for radio files or for RF engineer types. It's similar to what's called an electronically scanned antenna. So typically the antennas that most of us are familiar with is the big dish that sits out by the TV stations or, on your back of your house as you're perking up direct. That's a parabolic dish that concentrates the radio signals towards the centroid of the parabola. It's probably the wrong word. It's probably the locus or focus. I don't know, but not a mathematician. There's another type which takes a bunch of small antennas and puts them generally in a flat arrangement next to each other. If you've ever seen like a Patriot battery or an Aegis radar on a ship, it just looks like this flat panel. And what it does is it knows that the signals that it's receiving are all the same signal. So it combines those signals and assumes, since they're the same signal, it's able to eliminate some of the noise because it says, okay, this looks like the signal, this looks like the signal. So what's different between those must be the noise. So it essentially does it that way. We do a similar process with a subcomponent of the digital signal called the symbol. The symbol is the way the RF energy transmits the zeros and ones, and the symbol is what we essentially oversample, like the ESA radar or antenna oversamples the signal itself. So we can explain to those technically minded how this is analogous to another system in the process, so to speak, or another way of doing it. But it again is revolutionary in terms of how much impact it has. And originally, when we went to the modem manufacturers, which is the natural place that we would put this, they were skeptical again, and they would have to make changes to their hardware. And again, we're two guys, a dog, and a cat, so they weren't too. Regardless of my pedigree from the Pentagon, they still said, "Thank you for your interest in our radio, but we'll pass for now." So we built in our building and are about to deliver this week or so an appliance which we call the BoostBox, and essentially does this enhancement less efficiently in a standalone appliance that sits between the antenna and the modem. And essentially, it cleans up the signal and makes just the noise in the signal, and then passes that over to the modem to process. So again, we couldn't do this for the thruster. We weren't able to figure out a way to, bypass the point of resistance. For this one, we've essentially came up with a less elegant solution that allows people. You go back to things like the TiVo box, if you remember back, if you're old enough to remember that. TiVo could have been put on, and as is now on everything, right? You have this ability to stream and record and etc. But nobody accepted it, so they essentially went out and had to make a box to do that. So we're the TiVo of RF communication right now, and we hope, to migrate. It's much more efficient if we place ourselves in the modem and add our software essentially to the firmware of the modem. We can do all these things without, and they're much more efficient there because we're now with this new box where every box adds noise. So we're removing noise and then putting some more noise back in because our friends downstream don't trust us yet.
They doubt. Yeah. How can it be so good?
Exactly. If it was so good, why haven't I heard about it? That's the most selfish and self-absorbed view of the world. If anything was important, I should know about it. So because I don't, therefore you are wrong.
So, I mean, by the sounds of it, you said, yeah, you've approached few modern manufacturers, but now what stage is it at now, this digital signal processing software? Is it ready to go to the market, or is it
Well,
still in a prototype
we're about
stage?
to deliver a prototype. Again, we'll call them the appliance. We're about to deliver that in several of those prototypes to various paying customers who want to test it. So I would say it's way beyond concept now, where we've kind of converted it to hardware. And
You build a
hardware,
prototype now, you're
So
testing
we've
it with
got
different
multiple
clients. Yeah.
prototypes. They're going up testing. We've tested them and achieved improvement, a gain improvement, very substantial gain improvement. And then we have probably 18 customers wanting to test it in addition. And this one, unlike the satellite, can be put in play. I mean, unlike the thruster, can be installed tomorrow and start having impact and improve your performance right away. So if you go back to business models for a startup, this is a more attractive way to give
option than,
cash because the sales cycle is much shorter. They're both very, very, they're both pretty profitable products. They have software-like economics. In fact, the digital signal processing for the signal enhancement will probably sell as a SaaS or a HaaS, hardware as a service, or a software as a service type model because there are no alternatives to it. It's pretty much unique. So they should be quite compelling business opportunities from a financial standpoint, in addition
So
to.
once these 18 companies, whoever are now testing it, once they give approval that no, it works, and then they want to, become a proper client of yours, then you could approach this product as a SaaS or as you said, then that could be a really profitable business model then.
Correct. Yeah. So that's our plan. Right now, we've just been providing pretty reasonably priced prototype units for the testing phases. But, as our next step, we'll convert this into a SaaS model, or a HaaS model.
So you said these 18 clients, are they all based in US or is it
No, they're
global?
all over.
All over the world.
One of
Okay.
our prototype clients is actually in Israel. The other prototype clients are here in the States. But there's two target segments. The first is ground station providers, people who have ground stations, satellite ground stations that receive data from satellites. That's a service you can buy. So you don't have to install and set up your own ground stations. If you're going to make a constellation of satellites, you can buy the ground station and just pay for the data you use that you receive off your satellites. So there's a
Right.
number of those. There's a couple in Scandinavia, Korea, some in the United States, the UK. So lots of people, and these are international networks by definition, typically cover all over the world. They'll have places in Australia, they'll have places in Europe and Asia and
Yeah.
North America to capture the downlink from satellites as they go over.
Right. And what's the time scale you're looking at, like for these prototypes to being
So
accepted
God
as a
willing, we'll deliver our first one this week. We're
right?
again debugging not the tool itself, but some of the GUI. We have an issue that we're working on with the GUI, but that will work out. And then we have about 4 more prototypes to deliver that need, there are more for a telemetry client. So the other client that was quite interested in this are people who gather telemetry. Because the radio, let's say we're doing a hypersonic missile test, the radio and the missile is relatively weak because the job of the missile is not to transmit data, it's to blow people up. So typically those transmitters are not very strong, and the telemetry is sending out quite a bit of information. And if you need big antennas, now you have to have big ships out there that can handle the power and the scale required to have a big antenna. So what we're doing is helping those telemetry folks, and there's a number of them in the Defense Department, who want to get better telemetry, especially given all the hypersonic testing that's about to go on and is going on. They want better telemetry reception. So we are doing another one. There's a radio modulation format that's popular in the telemetry community. And so we are needing to add that modulation capability to our software. So we have to do that, and we'll build another 4 prototypes for those telemetry buyers.
Right. All right. So if I just move on the conversation to what are some of the challenges you are facing at Milespace? Like, what are one of your main pain points which you would want to solve?
Well, what is surprising to me is, I guess it shouldn't be surprising. The better your product performs, the harder it is to get people to try it. People like trying marginal improvement.
Yeah, if you're giving such a big improvement, they are more skeptical. Like, how is it even
So
possible?
that's been a much bigger issue than I thought. I'm bringing you something that can give you new capabilities. I'm bringing you a jet engine, and you're telling me jet engines are impossible. And we don't get to trying the jet engine. We just get to debating why it doesn't work and is impossible. And it's no longer about logic. It's now about emotion and ego. It's
Yeah.
not about, okay, if this worked, it could really good. So it's worth trying it. It's that, again, my ego is so strong that I can't accept that there are things in the world that I'm supposed to be an expert about that I don't know about. So it must be wrong. So that's been and it's true in both the products we've done, because we are doing revolutionary products that were designed using artificial intelligence 10 years ago, by and large, between 8 and 10 years ago, using physics-based models, using genetic AI tools to optimize and improve and evaluate multiple. And we came up with something that no physicists in the past, no people working on electric propulsion could have ever come up with in the time frame they did. So these inventions were made, the leading technology, which has been off patent for a decade, and was developed really probably in the 50s, maybe early. They had to simplify the math so much to come up with a design for electric propulsion. And the differential equations required to do the math that would be needed to analyze what we do would have taken a team of 1,000 mathematicians 20,000 years to do. So if you remember the most fun thing you got told in physics or engineering, assume there's no friction. I mean, that's what we're talking about. We're assuming there's no friction. We've simplified the world to such an extent that our feeble math in 1948, which was still significant, but not significant as it is today in terms of the computing capability, we simplified everything. And then the next PhD put his...
It's more like you have developed a perpetual machine, and you're saying like this goes forever, like with such small energies, and then how is even can it be?
But that one you can prove is physically impossible, but they assert that same mindset that because I don't know how it works and I put it in, they have a standard equation that only works for the products they've developed, but don't work for the product we do because it uses a different mechanism. And they put in the calculation, and we're saying they're saying E equals MC squared, and we're saying, no, well, E equals blue. It's not the same thing. It's not even the same stuff. So you're using a bad equation to do this, but they put it in an equation that they've always used, and because it doesn't work in that equation, then it must be wrong. So in any event, both on this and on the signal enhancement, we've gotten the expert you are in the field the more rude and obnoxious you are about our performance. So it's been really fun. The people who have less experience are much more open-minded to this. The people who think they're the experts, they get really upset and frustrated, and challenge me in conferences. Like, you have to say why this is. And it's like, I don't have to, right? You're not going to kill me if I don't. It's not my job to convince you. Well, you're a
Yeah.
scientist. No, I'm not a scientist. I'm a businessman. All right. I'll find the guy who needs this and I'll sell it to him. We'll figure out the science later. It's funny because we actually ran a program in New Mexico called New Space Nexus. And we were able to work with Los Alamos as part of this. And so we told them about our cluster, and we were struggling because it didn't fit the standard equations that were used in the industry. And they said, well, do you have experimental data? And we said, yes, we have a lot of experiments. They said, do you have simulation data, physics-based simulations? I said, yes. And they said, are they consistent? Yeah, they're consistent. He says, you don't need no stinking equations. That's what he said. We don't have stinking equations. We're at Los Alamos. We don't have stinking equations for a lot of things. We don't know how they work. We do know they work, and we can prove they work. But if Los Alamos gets away with it, why can't I? I don't know. I don't get
Uh,
it. So that's been a unforeseen and very big hurdle. If I was coming in with something 10% better, it'd be much easier to sell it. It was just doing the same thing everybody's always done and sell it. But disruptive changes. And another one in space was Elon Musk's assertion that he could land the first stage back on Earth and then reuse it. The biggest PhDs at NAFs said it was impossible. Again, they said the same things. My favorite story of this is the Wright brothers. The Wright brothers were testing their airplane about 6 miles outside of Dayton once they'd already gotten it going. And they called up the newspaper or one of the reporters at the local paper in Dayton. We're not talking the New York Times. We're not talking the Boston Globe. We're not talking the Chicago Tribune. We called the Dayton paper, the Dayton Flyer or whatever it is, and said, would you like to come out and see our demonstration of our flying? And the reporter said, that sounds interesting. Let me ask my editor. And so he goes to his editor of the Dayton paper. They know these people. And the Dayton paper editor said, no, you can't go up there. It's a waste of time. It's impossible for men to fly.
yeah, it is at that kind of magnitude you're talking about. That the technology you're talking about
Yes.
is something.
Again,
Yeah.
it's not in the world, but in the world of the people that are experts in what we do, it is like flying, and flying is impossible. So the only way I think you do that, the learning is you just have to demonstrate it over and over and over.
Yeah,
To where it's
absolutely.
impossible to deny. When you see the plane flying overhead, you can no longer
Yeah, once
deny
you
that you
see it in
can't
front
fly.
of your own eyes, that
Yeah.
it
You have to
is,
your
that's
ego gets, well, I always thought it was possible. The story changes instantly, right? Well, I thought it was possible, It's good. I'm glad they've done it, But anyway, sorry about that.
yeah. No, yeah. That's okay. So moving on from the challenges in the industry you're facing, what's your growth plan or the vision for the next 6 to 12 months? What
Okay.
MileSpace is looking at the next year?
So we're going to focus really on the signal enhancement product line. Again, because it's fastest to cash. It's a very profitable business. We have a lot of customers lined up, and we're delivering a product right now. We can easily replicate that. The manufacturing of this is very straightforward. It's just simple electronic boxes with the firmware loaded on it. So it's very straightforward to make. Should we need it, we have contract manufacturing, electronic contract manufacturing local to us that's able to do big scales if we want that. So we will focus on delivering those boxes, testing those boxes, selling those boxes, and then transitioning to a SaaS/HaaS model for that product line. We'll also be working with modem manufacturers to integrate the software once it's proven and they're now no longer arguing with us whether it can be done. We'll integrate it there, and we expect that from our testing, we have much better results there. Seems like our results will be another order of magnitude better than our box if placed on the firmware of the modem. So it has an even bigger upside in that format. So that's where we'll spend most of the time. We have a partner that is our sales agent for the thruster. that does a lot of work in small satellites and works with a lot of both the satellite manufacturers and constellation people, et cetera. So rather than us developing a sales force to do that, we've just assigned them agency. And as they sell products, we will um, either again through our own facilities or through contract manufacturing, deliver those thrusters to the market. So I would say it's focused on, the development is more focused on productionizing it as opposed to developing it. So it's more scaling it for production. And the business development is converting customers that are interested in testing into production customers.
Right. So in terms of the digital signals, so you already said you have some clients there. So with the SaaS model, how are you planning to market it to this SaaS model? Is it going to be again through that sales marketing agency, or you're going to plan something of your
For
own
this
to?
one, we have some sales agents that are
Right.
more kind of sales focused. We have some partners in certain uh, verticals, let's call them, that are doing some of the development. That one we probably will do more. Uh, for the satellite, the satcom side, I've already personally through the last couple of years met with and participated at conferences and other things. So we got them surrounded. They know who we are. We know who they are, and it's a matter of us delivering the product for their testing, and then they're figuring out where and how they would want to apply it. Similarly, that's for the SATCOM side. For the same product in the telemetry side, we have a government client that's very aggressive on this, that wants to see it, and it's some of these people are doing that kind of testing. And then we have several, but one primary modem provider in that industry and one primary antenna provider in that industry who are both very active in our development. So I think it'll be partner heavy. We don't have an aspiration to necessarily have to have, everything in house to do this. I think there are people, one of the quote clients we're looking at is a major communications equipment distributor. So they sell hundreds of different SKUs to people who are buying ground stations. So that's a natural partner, and we can provide them, again, a recurring revenue model product that they can start to sell, which, that is a very popular business model for providers to have that kind of capability. So they would be, a good choice because they already have all the business relationships in that sector, in that vertical. So again, that's kind of how we're kind of picking someone who's got a established business development partner, customer pipeline, credibility, Salesforce, et cetera. And we're trying to add this product to their kit bag and create something quite exciting that they can go into customers with and be a lead. I think it's always important for customers who are selling kind of boring things to be able to come in with an exciting technology play to kind of position themselves as a technology thought leader in an industry. So you're giving somebody some new kind of marketing patina that they can sell their other things with, but also gets a good meeting because people are very interested in this particular capability.
Right. Okay. That sounds really interesting. So Brad, okay, so if you want to just give a quick where do we find you, where the audience listening to you, where they can find you about.
Space-miles-space.com. Again, we have a website that talks about most of the stuff we're doing, and I'll be speaking at Telemetry Conference in Las Vegas in about 2 weeks. The International Telemetry Conference, I think it's called ITC, a convention, and then I'll also be speaking at MilSatCom Silicon Valley Space Week the following week in Silicon Valley, obviously talking about the digital signal processing product line. So those are places I'd be. And then anybody, if you get on our website, you can make a request. We've got white papers and whatever else people might need to if they're interested in what we're doing or just want to follow up. And I'm on LinkedIn I think I have a spaceman outfit on there, but we'll see.
All right. Thank you so much. Brad, it was really, really good insights into the industry. Thank you so much for your time today.
You're welcome.